Alright, so here's kind of a little bit of a demo of my scrolling display here. It's nothing compared to what a lot of big Redstone computers are, but it's still the biggest project I've ever done, and I'm pretty new to Redstone. So just to start here, I'll go over how they actually work in a bit. But I have a load function, a clear function, automatic clock, and a manual clock pulse, which I use the manual clock pulse in the loading procedure, but other than that, usually you're just going to use the automatic clock. Um, so these all, they do have some delay because they're going a good distance. So first I'll just start with, I guess, the screen here. So the pixels are made of 2 by 2 squares of iron trap doors. I chose trapdoors over redstone lamps, for example, because redstone lamps have a 2-tick shutdown delay. And since I'm running my display and memory banks and everything at 1 tick per 4 ticks clock pulse, essentially, um, that would just be a ton of judder and I guess technically almost kind of like ghosting. So it really it's rough enough as it is with this display speed. I really don't need it to have that extra judder and ghosting. I could probably run everything a little bit faster, but right now I do have everything timed for a 4 tick. I tried speeding it up and it didn't quite work right. But each module here is driven. So I have a bunch of data latches. They're repeaters that are locked with another repeater, and all of these that are currently red, they're synchronized to a clock pulse, essentially. So when that clock pulse turns off for 1 tick every 4 ticks, it will basically unlock all the repeaters and allow the signal to move 1 cell forward, 1 cell forward, 1 cell forward, etc. And it's all synchronized with itself. So this basically, the signal comes in and it shuts down these 2 redstone torches here, which shut down these repeaters. And every second repeater here, the ones that are just a single one long, those are set to 2 ticks to make up for the 2 ticks here. And those go into these hard power these blocks here, which have redstone torches in them. And those, I suppose it's called quasi powering or something. Anyway, they might just directly power these blocks here, which then power these redstone doors. Yeah, and it kind of double knots it here. So when you get an input signal that's on here, it will turn the display pixel on. And I chose a dark background here to hopefully help improve screen contrast. These here are my data lines, one for each set of pixel. This is a 5 pixel tall display. I think it's 5 by 56 pixels, something like that. Yeah, it should be 5 by 56. Anyway, these are my data lines. Oh, ignore that. That's an earlier version of it. A lot of these things around here are. Anyway, these data lines are all synchronized to take 4 ticks to arrive at the clock, and then I believe 8 ticks from the other end of the clock to the other end of the data register. So it's all synchronized to 4 ticks. But anyway, my data registers here have the data hard coded into them in these switches. Now, it could have used something like a character ROM, but one, I don't know how to do that, and two, I'm hoping to build this in an SMP server, and so minimizing resources is key. But each of these sections here is 28 bits, and I have 8 times 28 bits times 5 layers. So 5 pixels. But each of these works the same way as that screen. Essentially, you have a repeater that is locked. So if it has an off, it'll stay off. If it has an on, it'll stay on until it receives the next clock pulse, which will allow that to move that signal down to the next repeater. And that's basically what my entire data memory bank back here is. It's definitely not the most efficient space-wise. But I also wanted to add in here as a for the loading function, some tileable, somewhat compact AND gates. I'm not sure you can get much more compact than this. I did steal this design right off Reddit. Thank you, mysterious user from 7 years ago. But this way, it will only output the data that's in here if it also has a signal coming from my load switch. So that way, I don't have to reset this or whatever every time I want to use the display. I just load it into the memory banks, turn off the load function, and then I can start the clock signal. So that's mainly that. Speaking of the clock signal, let's come down here. My clock signal is very basic. So to first make the one tick pulse in the first place, I have just a button, and then a repeater lock, and then a delay here. So it'll essentially unlock the repeater, have a one tick delay before it ejects or before it shuts off, essentially. So there's one extra tick of time where the on pulse is allowed to go through, and that either goes directly into my other AND gate here, which is a little bit weird of a design, but I had the space that I had. And that goes with my clear function. But anyway, after that, it comes out into my synchronizing lines, or my clock lines. So it goes up here. The lower layers are synchronized to the upper layers. And then each data bank here, instead of trying to synchronize them all exactly, what I did was I synchronized them so that the data arrives with the same amount of additional ticks, or basically the data takes an additional 2 ticks here because it takes an additional 2 ticks for the clock pulse also to get to the next module. And so I just did that all the way down. As for the automatic clock, it's just a simple repeater loop here. I have one set to 2 ticks and the other 3 are set to 1 each. I believe that's 4. It's sure behaving like it's 4 because I'm pretty sure I timed everything for 4. And that has an AND gate which goes to my automatic clock enabling switch. So, that just will only enable this, which then goes through another AND gate. It'll only enable that if that switch is on. That AND gate here that I mentioned is for my clear function, right? So what it'll do is it'll essentially entirely disable the clock signal. So the clock signal works kind of the opposite of how you'd expect. When the signal is on, that's what locks the registers. It's not when the signal is on, that's when it's allowed to move, essentially. Now with these NOT gates and everything, I have it set up like that. But so when I turn on my clear switch, it essentially turns all of these lines off, which allows the data to just move straight through at 1 tick per section, which is basically the fastest speed I can do it. At the same time, it also turns off this AND gate here. And this AND gate basically intercepts the data coming back out of the screen, because the screen kind of acts as a memory unit as well. It's really interesting, just the way it's synchronized. Sorry about that, camera. But so that's data coming out of the screen. If the clear function is turned on, it will essentially disable, it'll stop that data from getting back into my memory banks, and it'll just clear everything through. Now, you do need to make good and sure that there's nothing left in these banks or it could screw up your data after you load again. But you should just have to, wait until it all clears off the screen, give it a few seconds, make sure that nothing's coming back through the screen. Because depending on when you clear it, there might be data in these registers that has to flow all the way back around and through and out. But so that's the clear function. I'm not sure how much more there is to say. The lower layers have extra ticks dedicated to them in order to stay synchronized with the upper layers. It may not exactly be necessary, I'm not quite sure, but regardless, just to make absolutely sure, and it probably is necessary, but just to make absolutely sure everything's in sync, I added extra delay to the lower layers to make up for the delay that's required to get a signal up here to these upper layers, because it just gets too weak to travel far enough. There's a 15 block limit on Redstone, which is also why I have everything in 14-bit modules instead of 16, which would be more common. It's because that's just how far the Redstone signal will travel in either direction for me. I could have done 8-bit modules, but at that point I probably would have been wasting a little bit more space. 14-bit was just the most efficient way I found. But yeah, these are the data return lines here, as you could probably tell. It comes back out of the clock, comes into the input of this register. Well, now that everything has been kind of explained, let's show the clock actually operating here. So, first thing I'll do is enable the load function, and if I follow this around, I'll just show you what it's doing before I actually do it. Don't mind this display, I need to break it at some point. That comes around the back here, comes around each module, and essentially it just activates the one side of all of these AND gates. So these switches can pass through whatever data they're holding, essentially. See on these data lines here. And this one is backfeeding, but it doesn't matter because there's a repeater there and the data's moving in the one direction. It doesn't cause any problems. But so yeah, that enables all of those. And then in order to actually lock the data into the register, and I do leave, so in order to lock the data into the register, I give one pulse here, which just activates the same thing I talked about before with the clock, which just provides a 1-tick pulse, an on pulse, which is then converted into an off pulse through my NOT gates and things. But that, if we come up and look here, let's just look here. So this data is on right now, so ignore that one. But this is the data that was just in that square. It's been moved there. So if I go down and disable load then, this is taking a little bit of time, and I'm not the best content creator, so you'll have to excuse me, please. But if I come up here, you'll see that that input should have been disabled at this point. Yes, so now we just have the data from all of them, and it's been moved 1 bit over. Now, this isn't absolutely necessary, but I do leave 1 extra bit at the start, just so I can store all of my memory within the memory bank itself. You could, it would be a good bit more work, but if you wanted to, you could load 56 bits, load them into the screen, stop the clock pulse, and then load more into the memory, and you wouldn't have a gap there. And you could fit more, because the screen does act as memory. However, you have to worry about timing, and that's just more work to remember to do. It's a lot more work. It's doable if you really, really needed the extra space, but at that point, I would just add more modules and figure out how to synchronize them all. You could absolutely just, take this whole thing and flip it 180 degrees and pop it back here, and then you'd have double the capacity. You'd have 16 24-bit modules for each layer. But so now that that's been disabled, we could manually step through the clock pulses, which I might do in a bit, but we will come in here and we'll just enable the automatic clock pulses and give it just a moment to work its way through all the repeaters and everything. And here we go. If you get too far out of render distance or too far back, sometimes you get some weird artifacting on the screens, I've noticed. Seems to be working okay for now, but I do also have my render distance and everything set up to 32 chunks. Just because this is a super flat creative world, there's not much that it's rendering. I'll have to test it with lower rendering and simulation distances and things. So there's a little bit of ghosting / judder, but it's not too bad. I'm not quite sure how I would go about improving that. If anybody has ideas, let me know. But yeah, so it says hello and welcome to Steampunk, which is the name of the mod pack that the SMP has on it. Now, all of the parts I've used here, I'm pretty sure, are vanilla. Well, the dark stone that I used behind these trapdoors might not be vanilla. However, you could use black wool or something instead, and you'd have even better contrast, but then you have to, dye all of that. But that would absolutely be doable with the vanilla block. So, hello and welcome to Steampunk. Woo! Alrighty, so we'll go ahead and disable this automatic clock, and all of these functions up here do have a delay just because they have to go through a lot of repeaters at 1 tick each just to get back to where they're, making changes. But so now we can click a manual clock pulse, and this will take a moment, but it moves everything forward by 1 memory cell, and it stays synchronized between the clock and the screen, or between the memory and the screen, excuse me. I'll go ahead and let this clear the rest of this out of the screen, and then I'll show you the clearing function, which I could do now, but I'll show you in just a sec. Hello and welcome to Steampunk. But yeah, most of the time, a lot of the stuff is just going to be hidden inside a well-lit box, essentially, except for the screen, and probably a lot of these levers and things are going to be in that box or whatever, behind the screen or underground or something, just so that your users aren't messing with it or whatever, just to, have it visible. There's not much I could do if a creeper comes and blows it up or something. I might try to encase it in some sort of glass to at least minimize the impact if something like that does happen. That's just SMP things. You can see there's a good bit of a delay here between the message looping or the message leaving the screen and it coming back through. That's because there's a little bit of extra room at the back of my memory cells that isn't filled. And again, also that extra 56 bits in the screen. Alright, so let's go ahead and stop the clock here. And we should get hello all the way on the screen. Maybe a little bit of and. Yep, got the first part of the letter A. And now we'll just hit clear. And this is what this does. It takes a sec, but it'll just essentially start scrolling all this through the clock and the memory as fast as it can. And then once it reaches the sand gate, it can't make it through because the clock or because the clear function is on, it won't make it through. And the clear function is also disabling the clock pulse, and that's what's allowing everything to go through. It's essentially telling it just go, 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 go. And I think everything's cleared through already, which is nice. It's pretty fast to clear. It's not instant, unfortunately. If I maybe there's some other way I could do it, or if I did it with pistons or something, but I really wanted to keep it all solid state, which I managed to do successfully. So anyway, now the memory is all cleared, but those levers that we used for loading, well, that's all still there. So if I wanted to, I could give it just a second to get back there. One clock pulse, so if I gotta get closer to the button. That'll load, and then turn off the load function, and then re-enable the clock signal, and the message should be there exactly as it was. This is also nice for if somehow you get an error in your display, you can just clear it out, reload it, no problem. Just, flip a couple switches, give it a minute or two, and it's all ready to go again with the same data that you encoded in with the levers. Now, it was a very time-consuming process and somewhat mind-numbing to encode it in with the levers, but if you're only having to do it once, or on the rare occasion where you change your message, it's not too terrible. It probably took me 15 minutes for this message, so obviously if you had a larger data bank and something longer, at that point you might want to start looking at doing something like a character ROM if you could, but again, I don't really know how to do that, so I just manually encoded every pixel for every letter, which an Excel spreadsheet helped me organize all of it to make sure it looked how I wanted. But anyway, thank you for watching if you made it this far. This is 18 minutes of a dude rambling and showing off his creation, so, if you've been here, thank you. And if not, well, I guess you weren't. Have a good one.